All right, everybody, welcome. How are you today? It's great to have you here for the stream. And yeah, maybe somebody could just give me a little chat, a little message in the chat just to let me know that I'm audible. Sometimes I get up here and I'm not actually audible to anybody, just talking to myself. I would much prefer to actually talk to all of you. So yeah, Monput61 says yes, audible. Thank you, both of you. Makes sense to confirm that I'm audible. It's just me up here. I used to be with Alberto, but now it's just me, and I have a dog with me here too, a little toy dog who's going to be sitting in on the stream. So yes, do any of you have a dog at home or any kind of pet? Let us know. Yeah, mine is Richard. So yeah, just a good opening icebreaker. Yes, hi there. Great to see you, everybody who's in the chat. And yeah, do you have a pet at home? That will be our icebreaker question for today. You know, even if you have a neighborhood cat or something like that, it could just be a really great way to get to know each other a little better in the community. Good day, Pharaoh. Justin Ayer says, yeah, I'm the pet. Yeah. And the penguin, that's pretty cool. Wow, I'd love to have a penguin named Pengu. Oh, and a fat cat and a normal cat from Jade. And Maysan says, I've got one extremely energetic mini Aussie and a very sweet golden doodle. So yeah. Oh, and Monput says, yeah, I do have a dog, although it's a stuffed toy. Yeah, me too. Me too. My dog is kind of funny because it can stretch out. Look at that. Isn't that interesting? And then get kind of flat. Or you can stretch him out in the other direction. He gets kind of chubby. So and Ari Likes Pancake says, I have a German Shepherd. Her name is Shelby, after the Shelby Mustang. I don't know what that is, actually, the Shelby Mustang. Oh, this is a cool car. Let's look at the picture of the Shelby Mustang, everybody, before we get started. Oh, that's a cool car. I guess I would prefer to have a blue car, but, you know, red is very stylish, too. Yeah. Well, if you haven't gone ahead and checked in yet, then please do so now. This is the link to check in, events.mlh.io/events/10896. And we're going to start off today with actually a stream called Machine Learning for Beginners. And the idea here is to go through a little bit of the basic concepts behind machine learning, and then we're actually going to apply them to a real world project. We're going to use a use case, which is to detect whether fruit is ripe or not. And you could imagine this being kind of useful if you are running a grocery store and you want to know when your produce is going bad. This could be a great way to know. So it could also be good for detecting diseases in your plants. Sometimes those diseases are on the leaves or the fruit itself. So we're going to do a real world application where we detect the ripeness of a fruit based on only a picture. All right. But before we get through to that, and Mohawk says, are we going to build that fruit ripe model today? Yes, we are. Yeah. So stay tuned for that, and we'll get to it very soon. But all right. So first, as I mentioned, let's check in. This is the link, events.mlh.io/events/10896. Really important to check in. It not only helps you by documenting really that you've attended the events and then gaining you some points, but it also helps us because we know what kinds of content you all are interested in seeing over Global Hack Week. Okay. And I want to now send out a survey. So this survey is going to be our first of the day. I'll post it in the chat as well. Let me know if you can see that. Let me know if you are having trouble with it. This is going to be our just icebreaker opening here. I want to know which of you have experience with ML in the past, what you're trying to get out of the workshop today. So yeah, if you could just complete this survey real quick, that would be great. Yeah, so today is day 5, and I'm wondering, is anybody here who has attended on all 5 days? Let me know if you did. All right, looks like folks in the chat are done. So maybe we'll wrap it up probably a little sooner than 5 minutes. That's kind of a long time, but let's see if anybody was able to attend for all 5 days of Global Hack Week. Fawnless says, missed the 3rd day. That's okay. You can't attend every day, and that's why we record our workshops, right? To make sure folks can get in on all the action. Okay, so we have 23 responses. Let's actually take a look at the form here. Present the results. Just love to see this sort of thing. So we have quite a few people who've heard of machine learning, but actually some folks who haven't heard of machine learning, which is great because that means that this is your first exposure to the subject. Oh yeah, you see some live updating here. A few people are trying to change the responses here. Okay, and then I asked, have you interacted with a machine learning model? And we have a majority of people saying yes, but some people saying no, and some people saying maybe. I think maybe might be the best answer here, because even if you have never programmed a machine learning model yourself, it's highly likely that you've interacted with one. We have chatbots, which are responding to your requests for customer service on a website. When you go to a when you go to a shopping website and they recommend you something, a lot of the times those recommendations are also informed by machine learning. And so those are just a couple of examples that you might not have known, but you were actually interacting with a machine learning model. So that's great. Okay, and now let's try this one. Have you trained a machine learning model? And the majority of you are coming in saying, no, you have not trained a machine learning model. And today that will change. So you are going to train a real machine learning model on a novel data set. And actually get a really good result. So I'm excited for that too. Let's see, are there things about machine learning that you want to learn? Of course, 100% of you said yes. That's why you're here at this workshop. And I'm excited that we will get to some of that stuff. And this final question I put in just for fun. Hack Week is truly a global event. We want to reach everywhere in the world with these virtual streams and provide the same content. So just for fun, tell us which continent you're logging on from. We have a lot of folks from Asia and North America and Africa, but also some folks from Europe, and I don't think anyone from Antarctica, but that would be super cool. And yeah, in Australia, it's pretty late right now, so I kind of understand why. But all right, well, yeah, thank you so much for your time and for joining today. So we're going to go back to our slides and go to really understanding what is machine learning. And I wanted to put this in as simple terms as I possibly could with this slide. So on the left here, we have a statistical inference. So statistical inference means that you are using statistical models to make some kind of guess about the future or about incomplete information. And so on the left here, you have statistical inference, and we now, because we have fast computers, we can apply these statistical models to huge scales. So instead of just calculating the average of 20 data points, now we can calculate the average of 2 million data points, right? Instead of calculating expectation values and moments and all of these statistical metrics on a small scale, now it's possible to do it much faster at these large scales because we have fast computers. So then on the right, I have here big data, right? Because before, it would take an enormous amount of effort to collect data, right? You may have to hire somebody to stand on the street corner and count how many cars pass by your store in order to know whether you have a lot of foot traffic at that location, right? And yeah, in fact, there were all kinds of people who would look at the night sky and classify the stars by hand, really. And now we have the internet, and the internet is huge because we can share our resources in data collection. There's other technologies that have enabled big data too, like satellites and mobile phones. But yeah, because we have the internet, you don't have to go looking for this data yourself. You can get it from somebody else. And we're going to witness that today, how the power of the internet is helping us with our big data. And machine learning is really only possible because of both of these advances. So you might wonder, well, we've had statistical inference for a long time, and we've had big data for a long time. So what gives? Why did we only get machine learning really blowing up in the past decade or so? And it's because of these factors kind of emerging together. And so now we'll cover what machine learning can do. And first, I'd like to cover a task called classification. In classification, you'll hear this term all the time in machine learning. It really just means that you're going to assign a category to data. So classification is done based on feature vectors, which include all kinds of information associated with a data point. So in this example here, I'm asking you to classify a fruit into a type of fruit. I guess I really like fruits. I'm not sure why, but so one feature might be color, right, of the fruit. Is it red? Is it blue? And another feature might be size. Is it in the palm of my hand, or do I have to hold it with two hands? And then the weight. So is it easy to, heavy or light? And so let's say I gave you a feature vector, which was, let's say it was green, okay? And fits in the size of your hand, and kind of light, maybe not so light, heavy, right? And so that could definitely fit into pear or apple, but it probably won't fit into blueberry, right? So our algorithm could detect that. One option for a algorithm could be the random forest algorithm for classification, just so we'll give you one example of an algorithm that could be used there. And let's do another classification example. And surprise, an image can be a feature, right? Because images have so many pixels that you could imagine, each of them having a different color. And so you could use the image itself as a feature vector and give that to your model. One option for this is a convolutional neural network, which aims to decompose the image into layers and assign those layers weights. And you can then use that as your feature vector for classification. And you can see all of these pictures are pictures of apples. So we could classify them that way if we had some kind of computer vision model. Okay, and here's another example of what machine learning can do. And we call this activity regression. So regression is the other big category of machine learning tasks in combination with classification. And regression really just means prediction of a value, a continuous value. So meaning it's not just an apple or a pear. It could be 3.14159, some number like that. And so I put this image of a stock prediction with LSTM, which was produced by Meta et al., this scientific paper. And they're using an algorithm which is called long-term short memory, which is a regression algorithm. You can look at the time series and get a good prediction there. So yeah, just really cool stuff, and very applicable to the real world. Let's look at another task, which is clustering. Actually, let's look at, before we do that, I want to look at generative AI, because this is also a form of regression in a sense, because you're predicting continuous values. And generative AI has become really popular with ChatGPT and things like that. But really, the goal is to imagine a new thing using user input as a prompt. So the algorithm will generate a new value, and that's based on the prior that the user gives. So here is an example, which is a generative adversarial network, which is a type of generative AI, as you can tell from the name. And if you were to give, let's say, the age, the eyes, eye color, let's say, perspective, whether the person's looking head on or from the side, and the mood, the idea would then be to use those user prompts to generate a person's face. And that face doesn't exist anywhere on the internet. And doesn't belong to a real person, but it is sort of a fake representation that could fool the average person, right? And this is an example of a specific type of regression task that has exploded in popularity recently. And now I'll go back to clusters, which we could identify clusters of data. So this is similar to classification, and indeed you are classifying into groups, but the idea is really a little bit different in the sense that you're not telling the algorithm what is a pear, what is a blueberry. You want it to naturally find these groups on its own. So you could think of this as a kind of unsupervised classification, where you're not telling the algorithm what the answer should be. You're just letting it arrive on there on its own. Okay, so now I want you to think of a new use case for ML. And we've seen several types of machine learning technology today. And I want you to actually come up with an application on your own. It could be something that you've seen before, but you're just kind of excited about. It could also be something I'd really like you to try, to think of something you've never heard of before, you've never seen it done, and maybe it would fit into one of these tasks. So go ahead and use the form that I just sent out. And this time will maybe take a little bit longer to really get those answers in. Let's give you 10 minutes actually to think about this, because brainstorming like this can be really helpful. So let's actually go ahead and take 10 minutes to do this. All right, everybody. That's it for our brainstorming activity. I wanted to give you all a lot of time to think about that because I think it's just good to have some brainstorming and let your mind wander a little bit. Um, yeah, Ralph Hack says, "Hey, just dropped by to say hi. Hi there. Glad to see you, and hope you have fun studying. Good luck with all your studying for the semester." Um, but yeah, actually, while we were in the break, I noticed that two people seem we may not be having. I might have gone a little too fast over those first few things. So I want to make sure that we all get it and stay. So I will be having another quiz to test your knowledge soon. But before we do that, let's go over some of these answers. Maybe that'll also help a lot. I think. So I have all of the answers that were given. And actually, ooh, that's a good one. Application of super resolution to astronomic images. That's very interesting. So maybe you could zoom into um, the skies with that. That would be really neat. So yeah. All right, and let's go ahead and go through, other answers as well. Great. So first, I have early stage cancer detection, and yeah, I do think that this would be a classification algorithm example because you are telling a person whether it is likely that they have cancer or that it is not that they have health. Like, it's not a situation where you would kind of have cancer, kind of not. At least as far as I'm aware. It's, and another person said, "What's your idea for a new personnel?" And the answer was, and they wrote language translator. And yeah, language translators can done with some sort of prediction and generative AI and multiple, as you said, multiple categories of use case because you are predicting what the words might be, while you're also generating new data, right? So this is a field we call natural language processing. So that's a great idea. And here, create and edit a website based on prompts such as words, colors, fonts, other websites, and screenshots. And the category here would be, yeah, as you mentioned here, it's more of a generative AI type deal. So yes, good, good. Thank you for doing that. And so let's see what the next one would be. An AI model to think about ideas for new use cases of ML. I want to know who wrote this one. That's great. Um, yeah, I mean, I suppose this is another question that we got from the chat to code. Um, does that question also allow us to talk about the use of robotics? And I guess not really. You're welcome to, but some of the techniques used in robotics, such as reinforcement learning, we are not covering today. Robotics is kind of even it's almost its own field of machine learning. Um, but yes, robotics would be another great application. All right, let's check another one that you all submitted. Medication, viral detection. Yeah, is your disease a virus or a bacteria? That is super important because it could help with antibiotics and things like that, to know that. And what is your idea for a new use case? Place jewelry on human faces for advertisement. That's a very cool idea. Um, yeah, like a virtual jewelry. I don't think I've ever heard of that, but that's a great idea. And yeah, I think I would like this next one. To identify hair fall in the early stages. I'd love to know that if I'm going to lose my hair or not. And tell, because that's kind of a common problem, especially for men, but also for women too. Yeah, but yes. So then we have this is interesting. So how can I have a plug-in ChatGPT into my local database? And so the idea would be to plug in your GPT model and it have you tell something about your data. Actually, I do believe that ChatGPT now has a data analysis plugin. So if your database is, if you could export your data to in some kind of JSON, CSV format, you could actually use ChatGPT for that. They have a plugin that I think you have to pay for that, a subscription, but yes, that exists now. So you check that out. Check out their data analysis. And then they say, what category? And this would be generative AI. Yeah, and I think you could also make a case for any of these, really, for analyzing data, right? All right, and another person wrote, identifying classical music by composer. Whenever I use an app like Shazam, it has a lot of difficulty identifying classical music. And even if it identifies the specific concerto, it has trouble figuring out the correct movement and composer. I did not know that about Shazam, that it had trouble with classical music. So that maybe could be a really great application business case. And yeah, I would agree. This is definitely classification because you are trying to identify a particular song, right? Okay, let's try another one. I don't know if it can be done or not, but I was recently using ChatGPT for college notes, but I had to take screenshots for them. I wish you could generate a PDF from an individual ChatGPT session. That's a great idea. I would love that because I want to sometimes save my ChatGPT session and not have to refer back to the ChatGPT website and just have a little document on my computer. That's honestly a great idea. You should build that. Yeah, you should build that, and maybe you could get a really popular tool. This is interesting too. This next one. How could, if we have a model that could detect deepfake attempts, like someone in your contacts tries to defame you, ask you for a deepfake scan, to avoid the upload of irrelevant contents of a specific person. Yeah, that could be really good. I mean, deepfakes, I think, will only become worse over time. I saw on Twitter this deepfake where a person was generated, an image of a person, and like, you know how sometimes they'll make you write like the name of the website or like your name on a piece of paper and hold it up to prove that it's you. Well, this deepfake actually had all of that included. So it's kind of hard now to even tell who online is real and who's not. Kind of scary, but also kind of, in a way, exciting to see, you know, how these technologies are improving. This is cool too, using ML to track animal migration patterns and predict future migration movements based on changing factors like climate and weather. This is super cool. And I read recently a paper where the authors were trying to predict where the, like, I think it was some kind of mammal, like dolphins or something, where they will go in the ocean based on the weather. And they used machine learning for that, which is super cool. I think they called it predictive ecology or something, or ecological forecasting. But anyway, it was really cool. All right. And another one we have here is ML that could be used in healthcare setting to determine whether a cell or tissue is healthy. This would be helpful for medical diagnoses for things like cancer. Yeah, definitely. And I agree, this is a classification because you would tell whether the tissue is healthy or not. And the idea here is environmental conservation. Yeah, there's so many ways you could do environmental conservation with AI, and as you mentioned here, robotics could be even an example. I could think of maybe robots that could, sort of identify an invasive plant, let's say, and weed that out, maybe, right? I don't know if that's even possible, but that could be a way to expand upon that theme of environmental conservation. And here's another idea: using computer vision to detect defects in a bridge. Hey, that's a great idea. And could maybe save some lives, honestly. And having an algorithm predict a lifespan or time until the fail becomes severe. Yeah. I mean, right where I live in Los Angeles, we just had this big fire underneath a bridge. And everyone's wondering, how safe is the bridge? When will we need to repair this, totally replace this bridge, right? Because it's been damaged, so it will definitely need to be replaced at some point. And then here, yeah, classification and prediction. Yeah, because classification, you could say, is there a defect or not? But then prediction and regression, I guess I should have put regression here, is a lifespan, right? So you could actually say a number. Yeah, weed it out. That was an unintentional pun, but thanks for noticing. And yeah, no, I can never tell who's real on the internet either. I was just talking to my friend about this. It's getting crazy. But okay, so now let's go on to another one. A model to stress test web APIs and networks to find vulnerabilities based on computer resource usage. Oh, interesting. I didn't know that goes beyond what the traditional detections services provide. Yeah, that would be super good. Because I know that those can be very anomalous. If you do get some kind of malware, you could all of a sudden see a spike in the computer resources. So that's a really good idea. And okay, let's see another one. I just am enjoying going through these with all of you. And if you haven't submitted yours yet, feel free to. We can update the forum. As we've seen in recent times, the use of generative AI in game development, in particular game engines, we might as well integrate it into visual effects, or to be particular, world building and model building in general. And that would definitely be generative AI. That is so cool. The idea that you could have machines building your worlds. That would be so cool. And Justin, I usually are all Steven's genius. Only the deep fakes. Only the deep fakes. But yeah, so let's go ahead and see this one here. It's detecting a specific pattern, maybe by knocking on the door to verify it's you and unlock your door. That's cool. Yeah, maybe people have different knocking patterns, and you could. I would actually say that this might be a classification task. I understand you wrote prediction here, and that's, yes, it would be a prediction, but I kind of meant regression in this. I didn't really mean prediction. But yes, this is also a classification, because you're trying to tell whether the pattern is you or not, right? There's no in between. There's no, oh, well, my prediction is that it's kind of you at the door. No, you can't predict that. You have to say yes or no. So, and then let's see here. You predict if a child is lost in the surrounding area using cameras. Yeah. I mean, I know for a fact that there are already efforts around the world to do facial detection, and do that with surveillance cameras. And there's a lot of, controversy and important ethical things to think about with that. But I mean, this could be a really positive thing, right? If you can find a child, that's super good. And you could use a CNN for this. Yeah, absolutely, because CNN is great for computer vision tasks, and especially classifying things. You could classify the face as that of the child. So it would be a great one to try. All right, let's see what else we have. Identify the weather today. Yeah, and we already have this, but I would say you could consider it classification. Like, for example, we have sunny or cloudy, right? But you could also say that it's regression, because regression is going to actually tell you, oh, it's going to be 57 degrees, let's say, right? Not 58, 57.5 degrees. So that's more of a regression. And here we have sign language translation. That is super cool. But I actually, yeah, that is generative AI, and you could definitely make the case for that. But there, you could also use some reinforcement learning and some other things we haven't talked about in that task. I'm just sort of trying to think about ways you could implement sign language implementation translation. And here we're running out of ideas here. So if anyone has a last minute addition, please send it in. But yeah, and here we have, I am a beginner in game dev, and the thing that I see with current gen AAA games, I guess that means a really high quality game. But I'm not sure. Maybe someone could correct me on that. But is that these are not very much well optimized. Yeah, yeah. So I don't know for sure if this is new or not, but it could be a good idea to use machine learning models for game testing. Yeah, that could be great. I mean, some of these games, I'm kind of amazed. They could be like 100 GB, 500 GB. It's kind of incredible. And I never really considered that you might be able to streamline those somehow with machine learning. Yeah, that's a great idea. Wow, you all are just full of great ideas. And let's see, an ML with an amount of logistics and case data that could predict the best case solution based on the client's country, product, and other factors. Yeah, that's true. And this would be an example of prediction. And it would probably be regression, because it is asking you to get a solution that might be on some continuous space, right? Maybe it has to wait at the warehouse for 23 minutes and then it departs for some other place. And so, and you could also use reinforcement learning, which we have not talked about today, but maybe we'll get to that. Although there are other workshops that we did on reinforcement learning. And here's our last one here. Identify how stressed you are and provide a stress percentage by facial expression. Yeah, that's a great idea. So I think you all have just some incredible ideas. And and even Rafa, so this is why we have our community here. Rafa, for those interested, there's an article about a guy that used GPT-3 for security analysis. Okay, so yeah, I mean, some of the ideas you come up with, you may have some friends on the internet that are interested in it too. So that's one of the great things about Global Hack Week, is we come together and we can meet some people who are interested in the same things you are. So if you're interested in any of these ideas, yeah, post about it in our Discord or in chat, and I'm sure everyone would love to hear from you. So yeah, okay, well that ends our activity, and now we're going to move on to some more things. And so I want to actually tell you about a use case for ML so you can get familiar with the concept. So we're going to do a classification task. The classification is going to be the ripened state of a banana. So we will take a picture, we'll take a look at some pictures of bananas and try to tell whether those bananas are ripe, or if they're too green to eat, or if they're just right, that perfect sweet but soft yellow banana. So yeah, now this application will involve transfer learning. And so we're not going to be needing a really complex computer, a really intensive computer allocation to train the model. It's going to be something you can do on your laptop with a CPU from Google Colab. That's going to be as simple as that, because we're going to use transfer learning. Okay, so let's actually look at what transfer learning is. So transfer learning is when you use a previously trained neural net to extract certain features. So in our case, we're actually using CNN algorithm, which is an extremely computationally intensive algorithm. Requires you to have a really nice GPU that can do convolutions really fast. And Then you add a final classification layer or regression layer, but in this case, classification. So we could use the final layer. It's much faster and requires less training data. So yeah, you could do a gradient descent to find the best solution. You could do a little random forest algorithm, anything that we've talked about to get that last thing. And that final layer is faster and requires less training data because you've already sort of learned the patterns, right? So I want to give you an example here. Have any of you ever done either of these activities? This is rollerblading and ice skating. So if you live somewhere where it's cold, maybe you have done the ice skating. All you need are some shoes. And rollerblading, yeah, all you need are some shoes with wheels. But let's imagine that you grew up in a place where it's not very cold. And so you learned how to rollerblade and you learned it super well. And then you moved to like Norway, where it's super cold and there's ice everywhere and everybody loves to go ice skating. So you want to learn. Well, it's going to be easier for you to learn how to ice skate than a total beginner because you're not going to be falling all the time on the ice. You already know how to balance on a skate from rollerblading. And even though it's a slightly different activity, you're going to already sort of have a framework. And that's exactly what transfer learning is about. So we have a few questions here. Use a methane sensor for additional data in real-time ripeness testing. That's a good idea, actually. Yeah, the more data you have, especially if they're from independent sources, independent lines of evidence, the better your detection is going to be. I mean, you have a picture of a banana, that's great. But a methane level would be an independent line of evidence that's gonna really give you even more data and help you increase your accuracy. So that's a really good idea. And then Darthsec says, what category does adversarial machine learning belong to? That belongs to generative AI, generally speaking, because what you're trying to do in that context is generate a output that will be indistinguishable from a human output to the machine. So you have an adversary, which is trying to tell between what the machine learning algorithm predicts and what a human would predict. And so, or what the real world would predict in another way, yeah, tell which one is the artificial output. So it's a generative AI, and actually, I think we looked at one of these. Maybe I'll briefly go back to that. So this is what, slide 13. Yeah, so we looked at the generative adversarial network. So in this case, this person, right? There's a second algorithm that would try to tell whether this person is real or fake. And the adversarial algorithm is optimized when the machine can't distinguish between what's real and what's not, or when that is it has as poor performance as it can get. And another question, could this be something like learning a new language like French if you already know another like Spanish? And yeah, exactly. That's exactly what it's like, because a lot of the patterns that you see in the French language will match Spanish, right? And there might even be some cognates, some words that are the same in both languages. So yeah, that's totally a good answer, a good example. Thank you for sharing that. And Zeronic said, can we get a general opinion on the OpenAI GPT store? So I've used it a little bit. I think it's pretty cool, but I don't have a very strong opinion. If anybody has used it and would like to share, please let me know. I used the GitHub scanner, actually. So that can be really good if you're trying to learn about a GitHub repository really fast. So I use that sometimes, but I don't like that you have to pay for a lot of the plugins that they have. Yeah. So, all right, we're going to do pop quiz number 1 now. So This is a way to test whether your learnings are keeping up with the stream. So why don't we go to this link and we'll give maybe we'll give 3 minutes to look at this, and I want you all to try and tell whether a use case is classification, regression, or maybe it could even be both. It's totally possible. So why don't you go ahead and fill that out now? We'll just give about 3 minutes for that. All right, everybody, that's it for our pop quiz number 1. And we're going to now take a look at this. But before we do, I wanted to point out this website that Xeronic sent out. This person does not exist.com. I was checking that out while you all were taking our quiz. And yeah, what an interesting website. I can't believe that's all the way back from 2019. All right, well, why don't we go ahead and look at the results here from the quiz. So, all right, let me share my screen and I'll show you the responses. So first, I asked you all, I am getting so much spam these days in my email inbox. I want to build a machine learning model that will help me with this problem. The model should automatically delete spam messages so that I only need to look at real emails. This is an example of A, and most of you said a classification task. That is correct. Classification, because you are going to tell the user whether a email is spam or whether it's not. So there's only those two options. You can't sort the email into both spam and the inbox. And yeah, regression could be useful here. We could maybe provide the email inbox with some kind of percentage likelihood that it is spam or not. And transfer learning could certainly be useful, but yeah, classification and maybe clustering are the ideas that we're looking for here. Yes, clustering too, because we could give it 2 clusters and tell it sort these into 2 clusters, but it might not necessarily know what spam looks like, right? So now, all right. So I want to build a weather app which will tell me what the weather conditions will be tomorrow. And this one had a lot more mixed response, and I think that's right, because classification could be used, right? You could say that we have a sunny day or a cloudy day, right? But really, I think regression is the best answer here, because in a weather model, you might be asked to tell what the wind speeds will be, right? And we want to be able to say whether the wind speeds will be 5 or 4, right? Oh, this is cool. A lot of spam classifiers also give a probability score and put it in email headers. Yeah, so that would be, it's definitely not wrong to say regression there. All right. And so, and actually, a probability score is not really a regression task. It could still be classification. And so now I want to write, I want to build an app which will recommend an outfit for me to wear. The outfit should match my feelings for the day. So I think a lot of you got this right. It could certainly be classification. But I really think generative AI is going to be the most helpful tool here, and probably the best category to pick, because you know, it's going to operate on a prior. So, for example, the prior might be, I feel happy today, right? And that's similar to in our face generation. Let's say we wanted someone with brown eyes, and so it's going to use that information to generate a something that could be really plausible response. So I think generative AI is the best use case here. And you could certainly use some of these other techniques, transfer learning, but yeah, I think generative AI is probably the best category there. All right, I collected seashells from 2 beaches. The only problem, they got mixed up in my cabinet, and I want to see whether I can still categorize them into 2 groups. So a lot of you wrote that clustering would be a good application here, and you are totally right. So clustering is when we only know that there are X number of groups, and the goal of the model is to sort the data into those 2 groups based on only the knowledge that there are just that 2 groups. Classification could totally be useful too, especially if I know that you know, one beach has a certain species and the other doesn't, and I could sort of sort them that way. But clustering was the answer I was looking for here, because I just want to see whether I can still categorize them into 2 groups. All right, so yeah, that's our quiz number 1. and I hope you enjoyed taking it. Let's go ahead and move on in our learning, which is about learning mode. So this is regards to unsupervised versus supervised learning. So in the supervised case, that would be more like our email spam if I gave the model examples. So I said, hey, model, here's some examples of spam emails, and here's some examples of real ones. And I want you to be able to tell which ones are which. On the other hand, unsupervised is more like our seashell example, where I'm saying, listen, here's a bunch of seashells, and I want you to group them into two, and you can use whatever information that you think is relevant for that, right? So that's unsupervised. And you can see that the type of learning that you choose is very dependent on the application. So unsupervised is a lot more to do with generative AI tasks. So generating a picture or a creative writing. ChatGPT is almost entirely unsupervised learning, although there is a lot of supervision that goes into that too. On the other hand, we have supervised tasks. So yeah, you could say that recognizing an image, and that's what we're going to do today. We're going to have a supervised learning task where we actually hand label the data for our model. And then there are some semi-supervised tasks. So this is like translation, right? So we're operating within certain framework, but actually there's a lot of possibilities. And so you could generate your own answer. And that's where we got into some interesting stuff with natural language processing earlier and detecting sign language, translating sign language. So yeah, that would be an example of a semi-supervised algorithm. All right, yeah, and here's where our task lies on this. So recognize a ripe fruit versus an unripe fruit. That's what we're going to do today, and it's going to be a supervised learning task. So this is pop quiz number 2. And I know we just did another pop quiz, but this is the last quiz, I promise. There's no more quizzes. It's just going to be doing after this. We're going to get our hands dirty and actually train a model. I promised you all would learn how to train a model, so I have to kind of keep my word, right? But there's the link right in the chat, you can see. And yeah, this is going to be a little bit more about what we just talked about. So supervised versus unsupervised and some transfer learning and things like that. So yeah, just go ahead and complete that real quick. We'll only take a minute or two for this one. So how about we just take 2 minutes for this? All right, everybody. So that's the last quiz of the day, I promise. There's no more of that, but I want to check over the answers with you all so that we can get some sense of what this is, because we didn't really talk too much about supervised versus unsupervised. I kind of just told you briefly. I wanted to use examples to really um, uh, help you understand that. So the first one is I wanted to tell whether a supervised model or an unsupervised model undergoes a training period. So this is the first question. And about half of you said supervised, about half of you said both, and then a few of you said unsupervised. But really, the answer here is both. So just because you don't have training labels on your data doesn't mean that the model can run without a training period. So in unsupervised situations, we are having a training period, but we're just not telling the model what to think in a sense. We're just saying, listen, look at this data and try to optimize according to some metric. And in supervised, we're saying, look at this data, look at the labels that we put on the data and try to match what we're doing, essentially, right? Try to basically become a human. Yeah, so it's a little bit of a different task. And so now it relies on human labeled data. We got a lot of folks getting the right answer here with supervised. So if you are a human labeling the data, that is a key hallmark for supervised learning. And finally, I asked, generally requires larger data sets to be effective. And this is super split, actually. One of you wrote supervised. I don't think supervised is really requiring larger data sets than unsupervised. Both, you could certainly make the category that make the assumption that both would be good. But really, unsupervised requires a much larger data set to be effective. And the reason for that is because by using supervised learning, you are, as the human, essentially putting in your own prior information, your own prior knowledge. And so that's going to really help the model a lot to converge on the right answer. In unsupervised learning, to get a realistic output, it requires a lot more data. So both of these answers, in fact, all three of these answers are kind of correct, but generally speaking, unsupervised tasks, especially generative AI and things of that nature, they require a really large data set. Okay, so now we're going to go back to our slides, and we're going to have our fruit ripeness computer vision hands-on activity. And I know a lot of you probably are waiting, have been waiting for a long time for this. We haven't been doing a lot of application-based stuff yet, so this is our chance to do that. And we're going to talk for a minute about our ingredients. So ingredients meaning, what do we need to cook up this computer vision model, this banana ripeness model? And the first thing we're going to use is a pre-trained model. So this model is called MobileNet v2, which is an object detection model that was trained on OpenImages v4. So OpenImages v4 is a data set of 9 million images. I'll show you that data set actually on TensorFlow. All this stuff is, it's basically public knowledge. You can see on there, OpenImages. This is kind of interesting, visualization. So yeah, here's a ton of data. I guess all the items haven't loaded yet, but it'll just have, let's see, is there any better way to look at them? Yeah, here's a better way to look at them. So here's an image of a pie, okay? An image of a wedding and the sneakers. You see all of these images are the same resolution, actually. Or they're kind of lower resolution is what I mean to say, and that's because we want to have as many as possible to train on, right? And the higher the resolution of the image, it takes much more effort to train. Right, here's some images with 200,000 pixels.
So these are a little bit more, I guess, high resolution. 300,000 is even higher. So, and then this, I guess, is the original. So, yeah. Anyway, this is the data set that's been trained on. And let me show you MobileNet now too. So MobileNet is, and this could look a little complicated, but MobileNet is an architecture. So you're using a convolutional layer to extract some features, to break down the features using convolution. And then bottlenecks are going to reduce the information content of that image and really extract those features. And then the answer kind of gets reshaped into the original form. So that's the idea with this MobileNet v2, and it can take a long time to train such a model on 9 million images with so many layers to it, so much going on. And we're not going to do any of that today. We're going to use our pre-trained model. The second ingredient that we have is our data set. And here I'm using a data set that was published by Saranya et al. 2019. I have the link here to their paper. And they are actually using deep learning to classify bananas to make them ripe or not. And the data set is available to you. So I'm going to actually paste a link to the data set in the chat, and we'll go check it out together. So let me share this tab that you all can see. So yeah, this is the data set, and you can see there is a green folder, and in this green folder is only pictures of green bananas. All right, so this is our first category. And we also have a folder with mid-ripen, which I guess just means that it's kind of ripe. Honestly, this is probably perfect type banana. I mean, look at this banana. This looks totally perfect. I would love to eat it. But let's look at another example of over-ripen. This is not good. Over-ripen is just kind of gross, honestly. Yeah, no, thank you. Good for a banana bread, if you've ever made banana bread. And yellowish green, I suppose, is another example of really an ideal banana, but maybe a little bit more on the green side, whereas mid-ripen would not really have any green. So it's been labeled for us already by a human. And so that sort of means that we're going to be doing supervised learning. All right, so that's our second ingredient. We have our pre-trained model, we have our data set. And the third thing we're going to have is a confusion matrix. So this is how we're going to tell whether the results are good or not for our model. And we can use this to tell how many of the predictions, which is the columns, predicted conditions, match the actual conditions. So let's say that we predict that the banana is ripe, and it really is ripe, then that would fall into the true positive category. And you can kind of think about all these different categories on your own, but that's the confusion matrix for you. And we're gonna optimize to try and find the best. We're gonna really try and make our model as good as we can based on this confusion matrix. So let's get started. The first thing you're gonna need to do is make a Colab Notebooks account. If you don't have a Google account, you're going to need to make one. I think most of you probably do have one already because you used that Google form that we had for the quiz. But if not, just register for a Google account. And then this is the tutorial provided by Colab, which is a computer vision transfer learning model for flowers. So it's really neat, actually. They have tried to classify flowers using machine transfer learning. I'll put the link in the chat to this TensorFlow notebook. And we're actually going to go through this notebook a little bit together. It's created by the TensorFlow community. And let's take a look at it really quickly while you all are getting your Colab notebook set up. So we can click run in Google Colab, this button here, and that's going to help us run it. So yeah, if you want to play around with this, go ahead and put it there. But the notebook says, have you ever seen a beautiful flower and wondered what kind of flower it is? Well, let's build a way to identify these. And they're using a CNN algorithm. And so all of these libraries get imported first. We import the TensorFlow hub, which is where we're going to get that pre-trained model from. The sklearn metrics library, which is where we're going to get our confusion matrix from. And all of these things to have a great training experience. And so the flower data set that they choose is an example data set from TensorFlow. And you can see they have a cell here for train fraction. So they're splitting up these flowers. They're going to say, hey, use 80% of these flowers to train the model, and then we'll evaluate the confusion matrix on the remaining 20% to see whether it can guess flowers that it's never seen before, right? So they have a function to split the data into these training and testing sets, the 80% test and the 20%, I'm sorry, the 80% train and the 20% test. And they shuffle those around. And so then they sort of download these. And actually there's 5 label classes in this data set: daisy, dandelion, roses, sunflowers, and tulips. So this is an example of classification, because the model's not going to say, oh, it's kind of half daisy, half rose, and a little bit of sunflower pinched in there. No, it's going to tell you what kind of flower it is, right? It can only be one species after all. And this model is using about 3,000 images. And that's going to be enough, really, for our supervised learning example here. Again, we don't need too many images, especially because we're doing transfer learning. So the model already knows a lot about classifying images. So, all right, this is just a few of the examples here of images in the data set. We have a dandelion, a rose. I suppose there's maybe some roses around this person's horse, and tulips. So you can tell that the images are sort of have a large variety, and we're really going to try and discern what the species is in all kinds of contexts. So then we build the model, and what we need to do is specify the MobileNet architecture. So we just put the link in here for the MobileNet v2. It's available on TF Hub, which is TensorFlow Hub, and it gets processed, resized. This is really important, decoded and resized to sort of break down all the information in the JPEG and make sure that all of those images are the same size. And then we can sort of use the TensorFlow to build a model. So we're going to use this dense layer to it's a very simple linear layer architecture to relate the features, which are the image data, to a classification. So this is just a single linear layer. And for each class, the model outputs some real number as a score. So it could output 1 or 2 or 3 to indicate the type of flower. And they use a loss function to relate that number to try and minimize try to essentially optimize the model to get the right answer the most frequently. So that's this idea here to calculate the entropy and do an optimization. All right. And so then we choose the predicted class with the highest probability as the correct prediction. And that allows us to do an evaluation, right? So now the next step is to train the network. So we will use it to train and see how it performs on our test set. All right. And so we can train it over a series of several batches of images and evaluate the model performance every 10 steps or so to see how it's doing at classifying these flowers. And so let's just look at this result of this file. So it's showing the test accuracy, which is the percentage of the data that was correctly classified in the test data set, which is that remaining 20% of data that we set aside and didn't train on, right? So at the first step, it's only getting about 27% accuracy. So it's almost never guessing the right answer. I mean, 27% is just a little bit better than random chance because there's only 5 categories. But as you get to step 10, there's a dramatic improvement, 50%, and then we get even better. And by the end of the training period, we're seeing accuracies that are almost 80%, right? So almost 80% of the time it's getting the right answer. And we could show the confusion matrix. Remember, we talked about this confusion matrix. So these columns are telling you the predictions. So if the model predicted a rose, then 60% of the time it predicted it correctly. If the model predicted a rose, then a lot of the times it was actually a tulip, right? So you could use this confusion matrix to tell which are the best ones. Sunflowers do really well. It's pretty easy to tell what a sunflower is. But some of these more trouble spots like roses, you could really dive down and try to improve the model on those. All right, here's some examples of where the model went wrong. So it thought that this image here was a dandelion, but it really was a sunflower. That's pretty tricky, I think. And then here, this is kind of a light colored sunflower, almost white, so I can understand why. And then here it predicted sunflowers, but actually those are tulips. I don't know why it predicted sunflowers here. That's kind of a strange one. But yeah, so these are just some mismatches. And then they have some exercises to improve the model. So we're going to apply this framework to our bananas. And the notebook that I sent you all I'll send it to you in the chat right now. This is an application to banana dataset. So go ahead and open that link to get started. And I'll share this with you too. So here we are, our application to fruit ripeness. And you need to just run the cells. So you run the copyright, and then here we have mounting to our drive. So you want to give this notebook access to your Google Drive. And so it can identify that banana data set. So our goal is to apply this transfer learning notebook to the ripe fruit data set. Okay. So actually, maybe I'll make this a little bit larger if I could somehow do that. Let's see. Any larger on your screen there now? Maybe I'll move myself to like the corner so that you all can see really well what's happening here. Okay, so first we will import all of these libraries just like we did in the notebook, example notebook. And instead of the flowers data set, we're replacing it with the banana data set, right, from that link we sent earlier. And the train fraction is 80%, just like last time. And let's go ahead and run this cell. Okay, so we get the check mark that it ran. And now we can download the images, split the data into train and test sets. In this case, we have 4 categories. It's not 5. It's green, mid-ripen, over-ripen, and yellowish green. And there are going to be 217 training images set aside for calibrating the model.
and 56 test images. So these are images where we want to evaluate the accuracy using them. Okay, so we'll explore the data a little bit, and this is just exactly how they did in the tutorial. We'll check out some of these images. We already looked at some of them before, but just to get your mind again refreshed on that. And then we build the model. So I'm using the same MobileNet v2 model. That's the great thing about a transfer learning protocol, is because we don't need to, this model could be useful for so many different things. Anytime you have images you want to identify, it could be great for that. So we run this cell, and now we're going to do some training. And this is going to take a while because we have 100 training steps, and they're carried out over the course of 10 batches. So we'll see down here, step 0 says 37% accuracy, which is almost just as bad as chance. As we get up to step 10 and 20, it starts to get better. And now we're seeing it converge at over 90% accurate. So this model is getting super accurate at detecting the bananas and their ripeness. Right? So this is what we call a convergence. So the model is converging. And let's show the confusion matrix to see where it's getting stuck. You can see that if the predicted label was green, then it basically always got that right. There's a few times when it mistook it for yellowish green, but almost always it gets green right. And the other case that it did really well on was over-ripened. So if you have a really bad banana, it did a great job at getting that. And actually, it never messed up. It never thought that an over-ripe banana was good to go. So that's really a key. I mean, if you're running a grocery store, you want to make sure that your over-ripened bananas get thrown out. So that's the only one the customer really probably won't want. So we just go ahead and predict that. And it did the worst on these middle categories, these mid-ripen and yellowish green. And sometimes it predicted that a yellowish green was really a mid-ripen, and vice versa. So especially in this direction, it's often saying that the thing is too green. So kind of interesting to think about. And we're going to take a look at the test examples that our model got wrong now to just kind of identify those. And you can see, indeed, there's a lot of these cases where there's a yellowish green mid-ripen mismatch. So now we're going to look at some cases to improve the model. And this is a way to achieve better accuracy. So the first suggestion they have is to replace our model with a different pre-trained model. And that's totally okay with me. I'd love to try that. So let me, oh, 1 second, I gotta just open this up. Yep, so all I did in this example is replaced our MobileNet v2 with a different version. So we were using version 2 before, and now I replaced it with version 3. So I'll paste that in the chat if you want to try a different transfer learning model. And yeah, well, let's see if we get any better result with this. I think I already ran it down here. Or no, I think maybe we have to run it again just to really. It'll ask you to connect to Google Drive and get your permission to look at your files, get your permission to look at those for its training. It's taking quite a while. Just going to terminate some sessions. Hopefully that will help it run faster. But yeah, you can see it's training the model again. And
we'll see. We'll see whether the training improves or not. Wow, this one's taking a lot longer. Maybe the model is more complex in some way. Although I don't think so. It should really run about the same speed. Let's look at our usage here. All right, we're about to cross the 90% mark. Can we get any better than 91%? I think that was where we ended on our version 2. Yeah, actually, it seems like it might not be getting there. We'll see. Yeah, I think this model is actually a little bit worse for our banana task. So you have to play around with these models, these pre-trained models, and see if any of them are better. Oh, no, there it goes. It's getting up to 91, just like the last one. But I think it has definitely more trouble than the last, than version 2. So I think version 2 is probably better for our banana task. Yeah, so I would say after looking at this training schedule, probably version 2 is better. Although the very last step here, it did get up to 93%, which is the highest of any. But kind of interesting. And here's another example of an update where they suggest that you try to mess a little bit with, let's see, what is it? A hidden layer. So here I've implemented a hidden layer. I'll put it in here. Let's connect again. And this is just adding an additional layer to the network, making the neural network a little more complex and able to handle additional relations between the data. So let me show you the model that I made. Super simple. Instead of having this one layer, I just added a second layer here, the hidden layer, and it's another dense layer. They told me to make it with 100 nodes and ReLU activation, so I did that. And you can do that too on yours if you'd like. But yeah, so let's see how the training is going here. If we add an additional layer, a hidden layer. And so the reason they call this a hidden layer is because it's actually not seen by us. It's kind of like an intermediate machine learning model. So it's like almost like having two different set of eyes look at the data, and like almost play a game of telephone to collaborate in finding the answer. All right, look, see, already on step 20, we're at 93% here. So, and we're already getting up to 95%. So this hidden layer thing was a really good idea, I think. It improved our accuracy quite a bit. We're getting a lot better result. So yeah. Let's try another one. I think the other idea was to change the training batches. I want to actually show you what happens if you stop the training early. So let me share that with you.
So in this example, we're going to do a lot less training. Oh, sorry, I wasn't sharing my screen there. Sorry, everybody. I had a little bit of a connection issue there, but let's see if our training is done. Yeah, so it's training right now, and you can see that the model only gets up to about 66%. So it's definitely not quite as good as if you push the training time more. And Chillin' Penguin says, had some problems with setup, but just got the first version running, so I'm wondering how to catch up to where you're at. And yeah, so I will post a link to all of these notebooks in the chat. Let me actually do that right now so that you can have those. So you got the first notebook running, which is great. And here is the updated version, update 1, which is where we change the transfer learning model. We change the pre-trained model, right? Let's see here. So here's update 1. And then we also did update 2, which was when we actually changed to add a hidden layer. And here's update 3, where we just finished. We reduced the transfer. We reduced the training time. So we only let it train for about 10 epochs instead of 100. So we got a much poorer result. And now we're going to do one more, which is update 4. And this one is going to be, oh, sorry, I'll make sure to enable the access here. All right, you should have access now. So let me know if you're still having trouble. But I'll give you one more, which is update 4, which is going to be I think in update 4, if I recall correctly, let's see here. We're gonna try a different optimizer. So we'll try the Adagrad optimizer and see how that impacts our answer. Adagrad means adaptive gradient, so it's allowing it to be a little more flexible in how it optimizes the loss here. So let's just try this and see what we get. Let's see here.
Just double checking to make sure all those notebooks are shared. It looks like they didn't really get shared. So now it should be that all of them are good to go. All right, let's see if it looks like we're just getting to training for this update 4. And we'll see if the accuracy, yeah, we get a much bigger accuracy here with the AdaGrad optimizer. So you can try all of these things. I mean, when you are training a model for an application of your own, try playing around with all of these things: hyperparameters, AdaGrad optimizer, and really that way you can get the best possible outcome. I'm sure that there are even higher accuracies that you can get than 93%, which I think is the highest we've gotten in our tests. But oops. There we go. Yeah, so it still has a little bit of trouble with mid-ripen. Yeah, it's tough to get these half ripened, half not. But this is so much better, actually, than before, because if you remember, our first case, we only had 60% accuracy on both over-ripen or mid-ripen and like yellowish green. They were both pretty bad. So, yeah. All right, everyone. Well, this concludes basically the workshop. So I wanted to now just have one wrap-up survey, and I'd love for you all to complete it if you can. Stick around for the last few minutes. And yeah, so we'll just give a couple minutes to complete that. Anyway, did anybody in the session, maybe you could just tell us, what are your plans for the rest of Global Hack Week? Do you have any other workshops that you're excited to see? Let us know. Yeah. All right, Chillin' Penguin says, looking forward to the GitHub styling workshop coming up. Yeah, me too. I really want to catch that one. I wish I had I feel like I almost don't have the time to do GitHub styling. But if I do get the time, I really want to improve my GitHub, make it look a lot nicer. Yeah, the GitHub style with Markdown. I know that's going to be really cool. All right, so let's try and look at this a little bit. The last survey we have for the day, and we're all done. Yeah, so we have a few folks. So finishing up their survey, so we'll let them. How to host Python script on a Raspberry Pi? Yeah, that would be cool. Yeah, Abhishek says, I need more ML to get used to it. And I totally agree. I mean, it's really, I remember the first time I looked at ML, it's really confusing. So it's just about repetition and getting more and more used to things as you go along. So yeah, let's check let's check this. So I wanna look at this. You're not alone, by the way, Abhishek. Here's folks. How do you feel about the basics of machine learning? We have some folks who are 5, which is awesome, but we also have a lot of folks who are less than a 5, 4, 3, 2. Thankfully, nobody feels a 1, so that's good. But you're not alone. It's not an easy thing to master, and it's just you have to have sort of exposure to it over time. So do you plan on using machine learning in the future? And most of you said yes, almost all of you, and maybe I could convince that one maybe that you should try it out. And then we had a recall question. So, and the recall question, I'm so happy about this. because the recall was, did we use supervised or unsupervised learning for our fruit ripeness detector? And 100% of you got the right answer. It is a supervised task. So thank you so much. I really appreciate that. You all spent the whole 2 hours here with me, learning some machine learning concepts for beginners. And yes, as Steve Dennis mentions, there will be a machine learning and AI, many more streams in February. We do Global Hack Week every month, and every month there is some machine learning topic. So yeah, I really hope that you can stick around for that. But yeah, thank you, Akand. And so this is the end. But connect with me on Discord, on our Discord community, or on LinkedIn. I'd probably check LinkedIn more than the Discord community. So yeah, in fact, I'll put that in there. I know nobody asked me to put it in here, but sometimes people ask me for my LinkedIn, so I'm just going to put it in to the chat. But yeah, feel free to share yours as well. Oh, that's all right, Pharaoh. Yeah, thank you for attending, and thank you for your comments in the chat. It's really great to have people in the comments who are active. It makes it so much better to have us all here, and it makes it so much more pleasant. All right, everybody, take care.